Welcome to this class. Today we are going to start our new chapter, Universe, of the Science and Technology of Class 9, and it is taken in Unit 12. And today we are starting the first part. The chapter is divided into 3 parts, and we are presenting the first part, and we are focused on life cycle of star. But before life cycle of a star, at least we must have a little idea about the universe and some of the basic components of the universe. That's why I want to start with a video clip which shows you universe a little nicely. Look at the clip. This is the travel to universe. We can expect like this. We are traveling to universe, and if it is so, then these materials, what is this? Do you know this? What is it? Actually, these are the galaxies which are coming towards you and going back, because we are moving forward and they seems to be coming back to us, and they are galaxy, and each of the galaxy is made up of billions of stars, and they contain huge amount of the cloud of hydrogen and helium also. They contain the solar system also, and maybe the similar system which we have as solar system, maybe the similar system present in other star also. Universe is very vast space which contains everything that exists. That's why we can define universe this way. Universe is a very vast space which contains everything that exists, like galaxies, stars, nebula, planets, satellites, gases, etc. Gases means the main composition is of hydrogen and helium gas is present in universe in different sectors, different parts in the galaxy. Okay, now let's talk about this galaxy. Before coming to this life cycle of a star, I want to tell you about the galaxy. What is it exactly? Galaxy is the vast collection of billions of stars and gaseous matter held together due to the gravitational force of attraction, and it is isolated in the space from the similar system. What is this? Look at this carefully. Collection of billions of stars are present in galaxy, and they also contain gaseous matter. I'm telling frequently about the hydrogen. Main gas is hydrogen and helium. Gaseous matter. And how do they held together? They held together because of the gravitational force of attraction, and one is isolated from another, and they can be distinctly observed. I want to show you the same again. Look at this. These are the galaxies, and one galaxy is different than other. They are isolated, and isolated system is forming in this universe, and each of them is galaxy. There are millions of galaxies present in the universe. Now you can just imagine how big the universe is. Okay, now let's go to another part, types of galaxy. I think you are taught in certain lower class also. There are mainly 3 types of galaxy. Now I want to show the animated video of galaxy. This is a spiral shaped galaxy. Stars are arranged in such an order that they form a spiral shape, and each of the star is rotating around a center, and this center is called galactic center of this galaxy. There is another spiral shaped galaxy. Look at this. This is animated file, and this is a little scattered stars in the galaxy, and it is also rotating around a point which is called galactic center, which lies in the center of the galaxy. This is another galaxy. Look at this. Is elliptical galaxy. This is spiral in shape, this is elliptical in shape, and this is the Milky Way galaxy. Milky Way galaxy means our galaxy. What it means, our galaxy means we are in Milky Way galaxy. Sun is present in Milky Way galaxy, and our solar system lies in the Milky Way galaxy. That's why we can say that this is our galaxy. What is it? The galaxy which contains about 10 to the power 11 stars, including Sun and the solar system, and it is spiral shaped is Milky Way galaxy, and this is our neighbor. I mean to say, this is near to the Milky Way galaxy, and this is Andromeda galaxy. This is the neighboring galaxy of the Milky Way galaxy. It is also spiral shaped galaxy. Now, spiral shaped galaxy are many in this universe. There is another type of galaxy also, which is irregular shaped. I mean to say, they do not form any definite pattern. We cannot say what shape it has. There are different shapes of galaxies. Each of them contains billions of stars, but the shape is not so clear. So, galaxies are classified into three types. One is a spiral shaped galaxy, and another is elliptical galaxy, and another one is irregular galaxy. There are three types of galaxy, and Milky Way is a spiral shaped galaxy. Earth is present in this Milky Way galaxy, and it contains about 10 to the power 11 stars. Okay. Now, after the understanding of galaxy a little, now I want to enter into the constellation. I mean to say, while looking at the night sky, we'll be able to see certain group of stars in particular direction, and the pattern of the group doesn't change. From hundreds of years, we are seeing those group of stars in different parts of the night sky, and this group of stars, which appears in a definite pattern, is called constellation. Now, what is constellation? Constellations are groups of stars which appears in a definite pattern in the night sky. Just for example, Ursa Major, Cassiopeia, Orion, etc. are constellations. There are 88 constellations declared, and among them 12 are called zodiac, Rasi. And these are some examples of constellation which can be seen from northern hemisphere. I want to show it. Look at this, is somewhat W shaped. This is Cassiopeia, and this is like hunter shaped. I mean to say, this Orion looks like a hunter. It is imagined that its shape is like a hunter, and this is Orion belt, which contains 3 stars, and it appears in the northern sky from northern hemisphere. And this is Ursa Major. Ursa Major, it is also called Saptarishi Tara Mandal, and it is also seen, it can be observed in the northern sky. These are some famous constellations which can be seen in the northern sky, and each of them contains few number of stars. That's why they are called constellations, and they are seen in a definite pattern. Their pattern is not changed. Okay. Now let's come to the star. We are talking about the life cycle of a star. At least we must have idea about the nearest star and biggest star and brightest star. I want to tell you about them, their name. Proxima Centauri. This is the nearest star from our solar system. Sun itself is a star, and the nearest star from the Sun is Proxima Centauri. And look at this, it is nearest star. And second one, Sirius. This is the brightest star which can be seen in the night sky, and this is brightest star. But another, UY Scuti. UY Scuti is the biggest star. First, I introduced 3 names: Proxima Centauri, Sirius, and UY Scuti, and they are nearest star Proxima Centauri, nearest star Sirius is brightest, and Y Scuti is biggest star. Where are they? I want to show their location also. One see it. This is Centaurus constellation, and its shape is like this. Actually, there is no any line between the stars, but it is imagined that it appears like this, Centaurus, and it can be numbered 1, 2, 3, 4, 5, 6. The stars are numbered, and this number 1 is Alpha Centauri, the brightest star of Centaurus constellation. This is Alpha Centauri. There are many. One is called Alpha Centauri A, another is called Alpha Centauri B, and another is Beta Centauri, Gamma Centauri, Delta Centauri, and one of them is Proxima Centauri, and we are interested with this Proxima Centauri because this is the nearest star from our solar system. Look at this diagram. Here is Sun, and this circle indicates the distance from Sun to 2 light year. This line represents 2 light year distance from the Sun, and this circle represents 4 light year distance from the Sun, and Proxima Centauri is a little away from 4 light year. It is at the distance of 4.246 light year from the solar system. That's why this is the nearest star of our solar system. I mean to say nearest star from the solar system. But don't forget, from the Earth, nearest star is Sun. And from solar system, nearest star is Proxima Centauri, which is a little reddish colored star. And its size is not so big. Its size is less than the size of the Sun also. Okay. Now let's go to Sirius also. There is one constellation called Canis Major. The Canis Major constellation contains Sirius. Look at this is Orion. Orion is a constellation. If we extend the belt of Orion in a straight line, then we'll get Sirius. Look at this, another diagram also shows the location of Sirius in Canis Major. This is the constellation Canis Major, and if a line is drawn from the belt of Orion directly downward in a straight line, then we'll get Sirius. And this is winter star. In winter we'll be able to see the Sirius, but it is actually seen clearly from southern hemisphere. In the winter evening, late winter evening, we'll be able to see this Sirius. Now look at this another diagram. This is the constellation Canis Major, and it is imagined that this shape is actually compared with the hunter dog. The shape is compared with the hunter dog, and its name is taken Canis Major, and this is one of the star of Canis Major. It is Sirius. Okay. Now look at this, can be seen this way also. In the night sky, if we remove these lines, then we'll be able to see these stars, and this one is the Sirius. Okay, this is the location of Sirius. Now next star, Scutum constellation. This constellation contains UY Scuti. This is the biggest star which can be seen from the Earth. It is very far away from the Earth. Look at its brightness. It appears reddish colored, and it is dominating the brightness of all other stars. It is very big star, and it lies in Scutum constellation. And these are the stars which are, I think, important, and you have to know about them. There are hundreds of thousands of stars which can be seen with naked eye also, but each of them are not so important for us until and unless we go to study about the life cycle of constellation. Okay. Now we are talking about the life cycle of a star. Now life cycle of a star actually starts with the nebula. Do you know what is nebula? Nebula means if we see the inner part of the Milky Way galaxy with simple telescope, in different places the patches of cloud-like structure can be seen. Cloud-like structure, not the cloud. Actually, these are mainly made up of hydrogen and a little helium and other particles. It appears as cloud. Cloud-like structure having a definite shape can be seen in different parts of the Milky Way. That is called nebula. Now we can define nebula this way. The patches of cloud-like structure that appears at different parts of Milky Way with the help of simple telescope are called nebula. And nebula actually later converts to nebula, later converts to star. That's why we are talking about the nebula. Nebula is present in Orion also. This point shows the location of one of the nebula in Orion constellation, and it is named as Orion Nebula. It can be seen in this diagram also. Look at this is Orion Nebula. It is just below the Orion belt. Now, it can be seen in this diagram also. This is the big shape of Orion. And this is the location of the Orion Nebula. And if we go close to this nebula, it appears like this, because this is the vast collection of dust-like hydrogen and helium gases along with other particles, and it is the dense collection of dust-like particles. And it appears in different shape. I want to show you other also. Look at this. We can imagine like this. A nebula contains huge amount of dust-like particles like this. And it appears like this also, the gray colored patches of cloud-like structure. In the background, in front of it, at the back of it, there are stars also. We are concerned with these dust-like particles which make a certain shape in the galaxy. Okay, this also, there are pillars-like structure, and this is nebula. There are many nebulas are present in this Milky Way galaxy also. Now, when the dust-like particles of this nebula comes closer and closer to each other, just like this, look at this. This is the nebula in which the particles of hydrogen and helium coming closer and closer to each other, and lastly, they forms a dark huge ball, and that dark huge ball formed by the collection of mainly hydrogen and helium gas is protostar. This is the beginning of the formation of star. Protostar is a huge dark ball of highly dense gaseous mass containing mainly hydrogen and some helium, formed by the gravitational contraction of gases present in the galaxy. Okay, now I am entering into the life cycle of star. Life cycle of a star can be shown diagrammatically like this. This is the representation of life cycle of star, diagrammatic representation. There are two lines. This is one line and this is another line, and there are possibility of formation of this part also or this part also. I want to tell you in detail. Look at this is considered as protostar in this diagram. The protostar is huge dark ball of mass which contains mainly hydrogen and helium, and protostar here formed. This is the protostar. And what happens in protostar? It doesn't emit light. When particle comes closer and closer to each other, then hydrogen also comes closer to each other, helium, hydrogen, whatever it has, comes closer and closer to each other. Then the temperature keeps on rising because of the friction. The initial temperature of this particle is estimated to be minus 137 degrees Celsius, but when they come closer to each other because of the friction, heat develops, temperature increases, and temperature increases in such a way that when they become compact, pressure also increases, and temperature when increases and increases lastly becomes 1 crore degrees Celsius, 10 to the power 7 degrees Celsius. This temperature is now responsible for the nuclear fusion, and at this temperature and tremendous pressure, hydrogen nuclei fuses with each other to form helium nuclei. Now a nuclear reaction produced. In this nuclear reaction, a part of the hydrogen, I mean to say a little mass of the hydrogen always destroys, and destroyed mass converts to tremendous amount of energy, nuclear energy, which is in the form of light energy, heat energy and other form. And because of this energy, now protostar converts to a star. It illuminates. and thus a star forms. I want to show this with a video clip. Look at this. This is the nuclear reaction which is constantly taking place in the central part of every star. Hydrogen nuclei are fusing with each other to form helium nuclei, and in this process a part of the mass of the hydrogen nuclei destroys, and that converts to tremendous amount of energy. That energy appears in the form of mainly light and heat energy, and a star formed. Look at this, is very interesting. Yeah, a star formed. Now it continues its life for a very long time. We are now from protostar to a star. Now this star formed. It continues its life for a very long time, millions of years, until and unless the hydrogen gas present in it is used up. Nuclear reaction continues, and until and unless it finishes, I mean to say hydrogen finishes, it continues its life. And so protostar converts to a star. Now protostar may convert to another big star also, giant star also. It depends upon the mass of the protostar. If mass of protostar is less, comparatively less, then it forms a normal star like Sun. But if the protostar, its mass is very huge, then it converts to very giant star. Look at this, is called big star or giant star. And have you noticed this? I'm showing here yellow colored star, but here blue colored star. Color of a star also depends upon its surface temperature. If a star has very huge surface temperature, then its color will be blue, and a little less temperature than this star appears white. If surface temperature is less than that, then it appears yellow. Sun is yellow colored star. And if surface temperature of a star is more or less than that of the Sun, then it appears red colored star. That's why color of a star also depends upon its surface temperature. A protostar can form very huge star like this, big star or a small star. Now the life of a star continues for a long time. Now I want to talk about the equilibrium of a star. In every star, there are two forces acting against each other. One of the force is called gravitational force, which is represented by a straight line with arrowhead, which tends to pull everything towards the center. Gravitational force tends to pull everything towards the center. But there is another force created in the central part of this star because of nuclear fusion reaction. Because of this reaction, the force, nuclear force, tends to push everything away from the center. These forces are acting against each other. Until and unless the balance exists between these two forces, the star continues its life. When this balance is upset, then the star will destroy. It will convert to red giant star. The life is now going to be end. Now I want to talk about the red giant star. What is it exactly? What is it? It is a very big red colored old star which forms when all the hydrogen gas is used up in the nuclear fusion and the star loses its equilibrium. When all the hydrogen gas is used up, then no more nuclear reaction takes place in its center. Then nuclear force is dominated by gravitational force. Now everything tends to go to the center, and helium formed by the nuclear reaction comes into the center, and the contraction becomes more in the center. And to balance this force of contraction, the size of the star increases, and temperature fell down because of the loss of nuclear reaction. And when temperature falls down, it converts to red color, and because of the offset of the equilibrium of a star, it becomes used. That's why the name is given red colored giant star. It is red giant star. Now I want to tell you about this a little more. Look at this. This is the diagram which represents the red giant star. Now do you know that the Sun later converts to red giant star when all the hydrogen gas contained in sun is used up in nuclear reaction, then lastly it also converts to red giant star. It is an old star. Now, when sun converts to red giant star, what is estimated? Its size increases and increases and it increases. It comes up to the first planet, Mercury. It engulfs the Mercury. Mercury goes inside the huge red giant sun, and then it comes up to this Venus also. Venus will also be engulfed by the sun, and it may come to the Earth also when it converts to red giant star. A day comes, but it takes millions of years. Now sun is in matured stage. In life cycle of a star borns and it becomes young and it becomes mature, and lastly it becomes old and converts to red giant. Millions of years later, the sun will also convert to red giant star. Look at this. This diagram represents the increasing size of the sun when all the nuclear energy, I mean to say all the nuclear reaction which is taking place in the central part of the sun finishes, hydrogen finishes, then it will engulf Mercury also, Venus also, it may come up to the Earth. Now let's come back to this cycle. Now what I told you, star converts to red giant star, and if the mass is very huge, it is big star, then it forms red supergiant star. Its size is bigger than the red giant star. Now what happens? We are talking about protostar, stars, red giant star. Now the old star is going to die. Now what happens after its death? How it dies? Let's talk about this. Now I want to tell you about the nova. What is nova exactly? In this red giant star, the outer part contains very less amount of hydrogen, which continues is a nuclear fusion, but when it finishes, then it explodes. Now the outer envelope of the red giant star explodes, and this explosion is called nova. Look at this. This is the nova, the outer envelope of the red giant star. I am not talking about the inner core. The outer envelope explodes, and the inner core is left over. And this left inner core, which contains mainly helium, converts to white dwarf star. Actually, I want to show you nova. After red giant stage, it converts to nova, and then the nova, after the explosion, what happens? The core is left behind. This core is white dwarf star. How it becomes star? The helium core again contracts, and during contraction heat energy again evolves, and because of huge amount of heat energy, temperature again rises, and when temperature rises to 10 to the power 8 degrees Celsius, not 7, 10 to the power 8 degrees Celsius, then helium fuses with each other to form carbon, and in this nuclear reaction the tremendous amount of energy again produces in this helium core, and this converts to white colored dwarf star. This is called white dwarf star. After nova, white dwarf star forms. Now how can we define white dwarf star? I mean to say, how can we introduce? It is a small sized white colored star formed by the nuclear fusion of the left out small helium core of red giant star. This way we can introduce this white dwarf star. Now, if it is very big mass of the supergiant red star, then what happens? It explodes in such a way that the explosion is so huge that the mass ejected by this explosion will be equal to the mass of the sun also, and this is called supernova. In case of red giant star we have nova, but in case of super red giant star supernova produces. This supernova is very huge explosion, and after the supernova explosion, the left out helium core forms either the neutron star or into the black hole. Now, before going to this neutron star and black hole, I want to tell you some differences between the nova and supernova. Let's see the difference. What is nova? Really, actually, what is the difference between nova and supernova? In nova, it releases less amount of mass in the universe. The mass released by this nova becomes raw material for the formation of another star. But in supernova, it releases enormous amount of the mass in the universe. An enormous amount means it may be of the mass of the sun also. That much amount of mass will be ejected by the supernova explosion. Next is releases less energy. Nova releases comparatively less energy, but supernova releases massive amount of energy. The energy released in 1 second in the supernova explosion is equivalent with the energy released by the sun in 100 years. How interesting it is. Look at this, it occurs often and more frequently. In a year, we'll be able to see a few novas, certain number of novas, but supernova, it occurs very rarely. After 50 years only, a supernova can be observed. Till now, I think 5 supernovas are observed, seen by the human. And next, it can occur more than once in the same place. Nova can occur in the same place more than once. When white dwarf star produces, then white dwarf star may collect some of the particles from neighboring stars and neighboring nebulas, and again nova can occur over there, but supernova, it does not occur in the same place more than once. Another difference, do not destroy the host star. If nova occurs in certain star, it won't destroy the neighboring star, but in supernova it can destroy the host star, near star. Okay, now I want to come back to this cycle where we were. This after supernova explosion, this is supernova explosion. Now what happens? Either the neutron star forms or the black hole forms after the supernova explosion. So what are the conditions for these two formation? I will tell you first about the neutron star. What is it exactly? The star formed by the contraction of the huge helium core left out by a red giant star after supernova explosion is called neutron star, which mainly contains neutron. What do you mean? After the explosion, left out huge helium core. In that core, what happens? Electrons and protons are pulled in the central part, nucleus, and they combine with each other to form just the neutron only. And that's why the major component of the neutron star is just the neutron. And look at it, it spins and it releases pulse. The spinning neutron star releases the radio waves in the form of pulse, and which is called pulsar. Either it forms neutron star or it forms black hole after supernova explosion. What is black hole exactly? Black hole is a very small remnant of the big star after supernova explosion, which has infinite density and tremendous gravitational force. Even light cannot escape out of its gravitation. Looking at this point, have you noticed this? This is very small remnant of the supernova explosion, and it has tremendous gravitational force. Even light, when falls on it, is absorbed. Light falling on the object is, if reflected towards our eye, we will be able to see that object. Otherwise, we will not be able to see that object. If light falls on the black hole, it will be absorbed by the black hole. That's why black hole is invisible. And it has tremendous density, infinite density. We cannot expect how much dense it is. Okay, I want to show this. Actually, black hole cannot be seen when it comes very close to a star. then it takes all the masses of the star in it. At that time, black hole can be seen destroying a star this way. Yeah, black hole can be seen when it is destroying a star. Each and every particle or the mass of the whole star will be taken up by the black hole. Now, it can be shown this way also. Exactly, there is no any hole at all. We have to be very clear. There is no any hole at all, but the mass is being compact and compact and compact. This type of black hole is present in our galaxy Milky Way also. When it moves from one place to another place, what comes in its path? Everything it destroys. Everything it pulls, and it will be absorbed by that black hole. Okay. Now, I want to show the same, the diagrammatic representation. Here, after the supernova explosion, if the initial mass of that star is greater than 1.44 times the mass of the sun and less than 5 times the mass of the sun, then it will convert to neutron star. Have you noticed this, what I told you? If the initial mass of the star is greater than 1.44 times the sun but less than 5 times the sun, then it forms what? Neutron star, because of the contraction of the helium core. Because when supernova explosion occurs, while exploding, implosion also occurs. It presses the central core and explode. And because of this implosion, it converts to neutron star or this black hole. The black hole forms only if its initial mass is greater than 5 times the mass of the sun. If it is very huge, then after supernova explosion, the implosion produces tremendous gravitational force and it will destroy because of its own gravitational force, converts to point-like mass, which is called black hole. If we compare the density of white dwarf, neutron star and black hole, white dwarf in 1 cubic centimeter, 10,000 kilogram mass is present in white dwarf. Just imagine 10,000 kilogram in 1 cubic centimeter volume. 1 centimeter length, 1 centimeter breadth, 1 centimeter height. You can imagine a cube of 1 centimeter contains 10,000 kilogram mass in white dwarf. But in case of neutron star, it is 1,000,000 ton in 1 cubic centimeter. But in case of black hole, it is infinite. We cannot say how much. And this we can imagine only. Okay, I think I finished this star cycle. As far as possible, I described every part. I want to revise a little shortly. Look at this first condition is protostar. This is a collection of huge amount of hydrogen and helium gas. When fuses with each other, then it forms a star. If the mass is very huge, then big star. And star continues its life until and unless there is a thermonuclear reaction in its center. And when the hydrogen gas present in it finishes, then it converts to red giant star because of the offset of the equilibrium of a star. If it is big star, it converts to red supergiant star, and red giant star undergoes nova. And this is the explosion which left the star, which left the helium core, which converts to white dwarf star. But supernova explosion forms what? Either neutron star or the black hole. Okay, I think today we discussed a lot about the star cycle. This is the star cycle, and we'll continue in another class also the same thing with different information related to the universe. Okay, today's class is over. Thank you.